Okay, now we're going to pick up from where we left off. So we're finishing H10F. So we were right around here. So investigation 3, we're doing question number 4. Okay. So consider the composite function, where y equals x plus 1 cubed. Okay, so write down the expression for u. So we're going to say u is equal to this part right here, x plus 1 cubed. Okay, and so now we're going to write y as a function of u. So we're going to say y is equal to, what was it here? Y is going to equal to the yellow thing cubed. So the yellow thing is u. So the original function was y is equal to x plus 1 cubed. So what we've just done is we're saying that this yellow stuff is called u. So I've got u cubed, and I'm going to say that u is equal to x plus 1. Okay? All right. Now, before we do this part right here, so the derivative of y, so we can say dy du is equal to, the derivative of this is 3u squared, and the derivative of this, du dx, well, the derivative of 1, that's going to go away, and derivative of x is 1. So I'm going to use this here and to find the product rule. Because dy du times du dx, we're going to say dy dx is equal to this first thing, which is 3u squared, and du dx, which is 1. Okay. Now, now I can substitute u. I'm going to replace u with x plus 1. So now I'm going to have 3 times x plus 1 and then squared. And that is the derivative. Okay, so how do you find the derivative of a composite function? So basically this is found using the chain rule. Which we just learned. I might want to hit pause and think about this, rewind. Let's do the next one here. So I'm going to say, I'm going to let u equal 3x squared minus 2. And then I can say y is equal to u to the 1/2 power, because square root is simply to the 1/2 power. So I'm making this part here under the radical, I'm making that equal to u. Okay. So so now dy du is equal to, using the power law, 1/2 u to the negative 1/2 power, and here du dx is equal to 6x. Okay, so now using the chain rule, I'm going to say dy du dx. So dy dx is equal to this thing, 1/2. I'm going to put u to the 1/2. I'm going to put it in the denominator. That makes this negative go away if I put it into the denominator, and then we've got 6x. Okay. Well, we know 2 goes into 6 3 times. So this simplifies to 3x times 1 over u to the 1/2 power. And so I can write this as 3x over square root, and u is 3x squared minus 2. Okay, you might want to hit pause to think about this some more. Okay, so this one here, I'm going to say, I'm going to let u equal 2x plus 3. All right. And I'm going to say y is equal to 1 over u. Okay, so the derivative, so this is the same thing as u to the negative 1 power, right? So the derivative of u to the negative 1 power, the negative 1 comes to the front, and now I have u to the negative 2 power, right? Power decreases by 1. The power gets multiplied to the front, and then u prime is equal to derivative of 2x is equal to 2. So now dy du and du dx, so dy dx is equal to negative u to the negative 2 power times 2. Okay, so the derivative of that times the derivative of that, so that's going to give me negative 2 divided by u squared. So I'm moving this u to the negative 2 power into the denominator so I can turn this power into a positive. And so now we can simplify this, and we get negative 2 divided by 2x plus 3 squared. Okay, I'm going to do one more example, and then the rest I'm going to just show the key and kind of walk you through it. So u is equal to x squared plus 4, and y is equal to u cubed. Right? I'm just saying all of this is u. And so dy du is equal to 3u squared. Du dx is equal to 2x. That's the derivative of this. This is the derivative of that. And we know that dy dx is equal to dy du times du dx. So that's 3u squared times 2x, which gives us 3 times x squared plus 4 squared times 2x, right? I replaced u with this stuff there, right? And then I can simplify this a little bit. 3 times 2x, so we're going to have 6x times x squared plus 4 squared. And there's my derivative. You might want to hit pause or rewind if you need to hear that part again. And I'm just going to show you my work for the next few problems. You may want to hit pause. You might want to hit pause. Okay. Here's the next one. You may want to hit pause. Okay, the next page. You may want to hit pause. And the last ones, you may want to hit pause. If you have any questions on these, or if you notice I've made a little tiny mistake, let me know, and I hope this helps.